Welcome back to Future Minds, Gen AI Data Science. I'm your host Manav. I'm excited to have you join me for our third episode. Today we are going to continue our exploration for neural networks, some advanced architectures and their applications. In our previous episodes, we covered the basic neural networks, including their structure, how they learn. Today, we will build on that foundation and explore convolution neural networks, recurrent neural networks, and the transformative power of self attention mechanism. Let's dive in. Let's start with convolution neural networks or CNN. As we mentioned before, CNN are particularly well suited for image processing tasks. They are designed to automatically, adaptively learn spatial hierarchies of features from input images. This makes them highly effective for tasks like image recognition, object detection, and even image generation. A typical CNN architecture consists of multiple layers, each serving specific purpose, and the primary block of CNN are convolution layers, which apply to set of filters to the input images. These filters are also known as kernels, slide over the images to detect local patterns such as edges and textures. This process creates feature maps which are then passed through activation function like ReLU to introduce non-linearity. Next, we have pooling layers, which reduce the spatial dimensions of feature maps in making the network more computationally efficient and reducing the risk of overfitting. Common pooling operations include max pooling, which select the maximum value of features map patch, and average pooling, which takes the average value. Downsampling process helps the network to focus on the most important features. To wrap things up, CNN typically end with fully connected layer that integrate the high value features learned from convolution layers and produce the final output, such as class scores. In the case of image classification tasks, CNN have been incredibly successful in a variety of applications, from autonomous driving, where they are used to detect classify objects, to healthcare, where they assist a diagnosing a disease from medical images. Now let's shift from a focus to recurrent neural network, that is RNN. RNN are designed for sequential data, making them ideal for tasks like time series prediction, natural language processing, and speech recognition. Unlike traditional neural networks, RNN have connections that form direct state cycles, allowing them to maintain hidden state that captures information from previous time steps. This ability to retain information makes RNN powerful, but they also come with challenges such as the vanishing gradient problem, which makes it difficult to them to learn long-term dependencies. To overcome this, researchers developed advanced RNN architecture like long short-term memory LSTM network and gated recurrent units GRU. Both LSTM and GRU introduce gating mechanisms that regulate flow of information, allowing the network to capture long-range dependencies more effectively. LSTM, for example, have three gates: input gate, forget gate, and output gate. These gates control the cell state, which carries the long-term memory of the network. The input gate determines how much of the new input should be added to the cell state, The forget gate decides how much of existing cell state should be retained. The output gate controls the information passed to the next hidden state. GRU, on the other hand, simplify the LSTM architecture by combining forget and input gate into single update gate using reset gate to manage the flow of information. This makes GRU computationally more efficient while still capturing long-term dependencies effectively. Both LSTM and GRUs have been successfully applied in variety of tasks. In natural language processing, they are used for language modeling, machine translation, text generation. In speech recognition, they help in transcribing spoken language into text. They are also used in time series forecasting, where they predict values based on the past data, such as stock price and weather patterns. Now, let's talk about one of the most revolutionary advancements in the neural network, the transformer architecture. Transformer architecture have transformed the field of natural language processing by enabling the training of very large model that can generate coherent and contextual relevant text. They can innovation they the key innovation of transformer is the self attention mechanism, which allows the model to weigh the importance of different words in sentence when making prediction. Self attention enables the model to capture long range dependencies, contextual relationship more effectively than the traditional RNNs. In the transformer, each word in the input sequence is represented by an embedding, and self-attention mechanism calculate the importance of each word relative to the other. This allows the model to focus on the most relevant words when generating the output. Transformer architecture consists of an encoder and decoder, each composed of multiple layers of self-attention and feed-forward neural networks. The encoder processes the input sequence and generates set of hidden representations, which decoder uses to produce the final output sequence. This architecture has been foundation of many state-of-the-art models, such as OpenAI GPT-3 for text generation and Google's BERT for language understanding. Transformers have enabled significant advancements in the generative AI. For example, GPT-3 can generate human-like text based given prompt, making it useful for tasks like writing essays, creating poetry, or even generating code. The success of Transformers has inspired innovations in other areas such as image or music generation. Let's bring this back to practical applications. Imagine you are developing chatbot for customer service using transformer based model. You can create chatbot that understand and responds to customer inquiries in natural language, providing seamless and engaging experience. Or consider a recommendation system for streaming service. By analyzing users' viewing habit or preferences, a neural network can suggest personalized content, keeping users engaged and satisfied. As we continue to explore the world of neural network, it is important to consider the tools like frameworks that makes it easier to build train these models. TensorFlow and PyTorch are two of the most popular frameworks providing building blocks of developing cutting-edge AI models. TensorFlow, developed by Google, offers comprehensive ecosystem of machine learning, including tools like model development and optimization. PyTorch, developed by Facebook, It's also known for flexibility of ease of use, making it a favorite among researchers and developers. To get started with this framework, you will need a solid understanding of underlying principle of neural network as well as practical experience in coding data analysis. There are plenty of online resources, tutorials, courses that can help you to build these skills whether you are beginner or experienced practitioner. Before we wrap up, let's touch on some of the challenges, ethical considerations in deploying neural networks. Training neural networks require large amount of data computational power which can be barrier for many organizations. Additionally, the risk of bias in AI models which can result in unfair discriminatory outcomes. It is crucial for consider this issue and strive for fairness and transparency in AI model. Strategies like transfer learning and pre-trained model is fine-tuned on specific tasks can be helpful for reduced computational requirement and data needs. Model compression techniques such as pruning and quantization can help making neural network more efficient. On the ethical front, ongoing research and regulation are needed to ensure that AI systems are developed and deployed responsibly. Thank you for joining me today, Future Minds Gen AI Data Science podcast. I hope you found this helpful, this topic, and make sure to subscribe my channel. And if you have anything, comment. Please comment down uh, any question or anything. Until next time, I'm Mano signing off. Stay curious, stay inspired, keep exploring the amazing possibility of generative AI data science. Thank you.